My network connections are okay. All right. Well, good evening, everyone, and welcome to today's session. Today, we are continuing our discussion on ethics and safety in agentic AI. As usual, we'll start the session with a recap of what we talked about in the last class. So, who volunteered to give us a summary of what we discussed on Tuesday?
Okay. Okay. So I think last week I think that was like Tuesday, right? And my Tuesday was
Yep.
a very my practical section. Like we had a lot of like discussions too as well. But what I took was we discussing about responsive, responsible AI. And when we say responsible AI, like we are basically saying the artificial intelligence like being developed by the developer follows a set of operational guidelines which is being used for safety, transparency, and accountability. So with me talking about safety, accountability, and all of this stuff, like we also spoke about the core responsive responsible AI and my principles. And we have accountability, we have um, we have transparency, and we have privacy and my content. So with
Con-
accountability,
consent, you mean?
okay, yes, yeah, my thank you for that. So with accountability, there has to be someone who needs to show own up for the AI's outcome. And with the transparency, the system that you are building needs to be open, honest, based on its like building block. And I mean, when it should be okay, so I think it should like disclose a certain like amount of like information. Example, maybe when it's like generates an image, it should be fed to us and tell us that this image was being generated by AI. And when it has limitations, it should also let the user know that it's lacking at a particular angle. And with the privacy aspect, the content of the system that we are building has to protect the user's information. So, like those were the core aspect that we talk about, and we also talked about ethical tools too as well. And we have for the okay, so for those tools, there are fairness and barrier and detection, and those tools are AIF 360 and AIF 360 and And for explanation purposes, we also use a tool called Sharp and Lime for those purposes. So and that's what I can recall based on Tuesday's section. And I thank you for giving me an opportunity to speak.
Okay, thank you for that. Lara, would you like to add something?
Yes, sir. I don't know if I'm. What do you say?
Go ahead, please.
All right, sir. I want to add to what Bennett has said. On Tuesday, we started off with the topic. That's ethics and safety consideration in AI development. And I remember well, when you started with us was to tell us about some three pillars of fairness in agentic AI. That is, there are some three key factors that must be in consideration while developing AI systems. And they are distributive fairness, procedural fairness, and representational fairness. He told us that distributive fairness talks about who gets what. That is when something is about to maybe to be, let me literally use the word shared. Something is to be shared or some benefits needs to be given to some people, maybe out of a pool. And that assignment is seconded to an AI system, an agentic AI to overtake or to undertake. So we want to be sure that it is fair in that distribution. And that distribution is talking about maybe statistical distribution. So that does the agent offer the same discount, for instance, to everybody from the same locality? Or does it give some other persons in some other areas, maybe because they are larger in number by their population or due to other factors? Does it be a bias to them? Then the other aspect of procedural fairness talks about the procedure, the logic used in such a criteria. I mean, as a criteria used, does the agent use the same criteria to evaluate resume? For instance, if a job application is to be assessed by resumes submitted and they want to maybe invite people for interviews, and it's ATS, they call it automatic tracking system or something, one system that ranks resumes. If I mean, we want to be sure that that system is fair in the procedure or the methodology or the logic behind the scene under the hood. Is it consistent? That's our concern, fairness about procedure. And last, the third one for the representational fairness. We want to know if the agent doesn't follow stereotypes. We want to be sure if it avoids stereotypes in production style. We went further to tell us, we discussed participatory in the class about equity and equality. That equity is giving every user the exact prompts, while equity factors some adjustments to bring some fairness to some marginalized groups. And we discussed, even though there is no, yes, I mean, positive or negative, I mean, right or wrong, but we understood during that. And then you took us to understand the trade-off between fairness and utility, such that if we are trying to be fair, accuracy may be traded off or efficiency, so to say, because ideally it's like we are trying to maybe kind of force the algorithm or force the model or the agent to do maybe something that it perceives is the right thing to do, but based on human standards, human ethics, we we adjust it. So there's a trade-off between utility and fairness. We call it tension between an agent's raw performance and its ethical alignment. And I guess that's where the human look comes in. I say adding fairness constraints to decrease the overall performance, like I said, of the model. And that agent developers must decide where it lies. As in, there's no, there's no fast rule about it. Maybe situations or use cases will determine what should be done. And like Kenneth also mentioned, told us about the core principle of AI, accountability, transparency, and privacy and consent. Accountability is owning up to what has been done, as in somebody must be accountable. If anything goes wrong, somebody, I mean, it will be factored into the development that if this happens, this is the person that will be held responsible and the likes. The transparency, I mean, talks about making the user know what is how their data will be handled, or rather, the user needs to have an idea of what is happening and how yes, how the algorithm is as much as possible, because everything may not be open. I think that's where the area of explainability comes in. Then the toolkit, we took also the toolkit, in coding and the likes. It told us that AIF is by IBM, while FLX is from Microsoft, and we do some hands-on uh, around that. I think that's the bit I can also speak to, sir, as far as what we did on Tuesday is concerned, sir. And apart from that, during the live code session, it told us the two different. One is the AI, like I said, AI 360 and Sharp and Line. How these tools, where we had some hands-on, some hypothetical data sets on how due to different regional representation and speciality, and how the agent is able to uh, get accurately this prediction compared to the ground truth. And we looked at the accuracy, precision, and recall, and how these change with some adjustments in the whole thing. That's a bit I can speak to, sir.
Okay, thank you very much for that. I think together you've covered reasonably well the recap of what we did on Tuesday. So I think we'll just move ahead. So today we'll start talking about bias detection. Well, last on Tuesday we will talk about fairness. I mean, fairness is more or less the absence of bias. Well, the absence of discrimination. Let me say, so bias relates with discrimination. So, how do you detect bias in your agent? And if you can detect bias, then that's the first step towards trying to um, evaluate or audit your agent for fairness, and which enables you to correct any detected bias for you to have a fairer and more ethical agent. Um, the first thing we'll talk about will be demographic parity. Um, Essentially, that's the likelihood that um, for different demographic groups, a request will be successful. I mean, if a request is successful for group A, the likelihood that it will also be successful for group B. If there's a higher likelihood, if there's a higher success for group or the other way around, then there's no demographic parity, which indicates that there's a bias against the group with a lower probability of request success. The other thing is equalized odds. Essentially, the idea here is that the false positive rate of the agent, false positive rate is um, the rate of false positives. I mean, what's the percentage of the positive um, responses, the positive labels from the agent's output that is false? I mean, something that's supposed to be in truth is should be labeled as negative, but the agent labels it as positive. An example will be the um, expert recruiting agents that we used in our demo code on Tuesday. Now, if you have an expert whose skill does not for is not one of those that are required for the task, like an expert whose skill is in writing, and then these are agents recommends that that expert should be recruited. That's a false positive. So equalized odds simply is the concept that no group should have a higher false positive rate when they are evaluated by the agent. Well, in the case of that are agents, it actually has bias, but there's no demographic parity, and then the equalized odds is also poor because it essentially was anybody from the, I think from the global north, he just recommends that person for recruitment, and anybody from the global south, it recommends not to recruit that person without considering um, whether such experts are actually qualified, whether they have the requisite skills for the task that experts are being recruited for. The other metric would be disparate impact ratio. The idea here is that the success rate for I talked about this. That was one of the metrics that we calculated in demo code from Tuesday. So if the success rate for any group is less than 80% of that of another group, then there's a bias against that group whose success rate is lower. So essentially, every group's success rate should be greater than or equal to 80% of that of the group with the highest success rate. If that happens, if all group success rates are within 20% of each other, then I mean that's acceptable fairness. Any question? Okay, so we move ahead.
Sorry, sir. Please, I want to ask a question. I
Okay.
saw something Pareto last week, and I heard you talking about 80-20 now. Is it about the same Pareto principle we know? I'm not very sure.
If the no, the Pareto this thing from last week was about utility fairness trade-off. It was about the utility fairness trade-off, right? How at what point? What is the sweet point where you have optimal utility and fairness, so that it's fair enough without the utility being so low that the agent becomes useless. I mean, if your agent is 100% fair, but it definitely doesn't achieve anything, that agent is not of any use. So while you want your agent to be useful in the sense that perhaps it has good accuracy, the accuracy is high, the precision recall and all that. Improving fairness usually involves sacrificing some utility. So what's that point where you have good enough utility as well as satisfactory level of fairness? That was what we are referring when we're talking about Pareto. What was it from last in the last class here? I mentioned 20% because if the success rate of the group with the lowest success rate, if its success rate is not less than 80% of that of the group with the highest success rate, the implication is that the success rates of every group are within 20% of each other. I mean, I just did a simple math of 100 to 80. It's not a Pareto distribution. In this case, that's not.
All right, sir. Thank you, sir.
Okay. It's just coincidental here that we are having 80 and 20. But I mean, the 20 came from just subtracting 80 from 100. Okay, so now from bias detection, we are looking at safety. So when you detect bias, you need to address it, right? Now, if your agent is biased, it may not be very safe, right? Those metrics, those pillars we need to look at when we're talking about fairness. And of course, fairness is relates to absence of bias. How do you ensure safety in your agent? And that's what brings us to the multi-layered safety paradigm. In traditional generative AI, security is essentially focuses on um, avoiding or minimizing misinformation. So security is about how do you prevent your agent from hallucinating? How do you prevent your not agent now? How do you prevent your model? How do you prevent your application from hallucinating or from providing incorrect information, misleading information, right? That's in traditional generative AI. That's the basic focus of security. But agentic AI goes beyond just outputting text. Agentic AI, in agentic AI, your agent can take action, right? Your agent can take action. And some of those actions, some of them have impact in the physical world. For example, if it's an agent that's monitoring, let's say a nuclear power plant, if it makes an error, that could be catastrophic, right? Or if it's an yeah, I mean that's if it's an agent, for example. Yeah, typical like here in Nigeria, most traffic lights are just timed, and so you see situations where on this lane is showing green, but there's no car there. Meanwhile, on another lane where there are cars, is showing red. The efficient thing is, I mean, if there's no car, keep that lane on red and only start using time as the basics for switching the signals when you have cars on multiple lanes, right? So um, let's assume you have an agent that's controlling the traffic light. If it detects more cars on this lane, it gives them more green time compared to the lane that has fewer cars. And let's also assume that this agent is smart, that it's able to be provided data, maybe uses whatever a hook or something when maybe there's an emergency vehicle moving on a particular route, maybe an ambulance is trying to move an accident victim to a hospital. So it tries to keep that lane on green when the ambulance is passing or something. Let's just imagine such an intelligent traffic light control agent. I mean, the action of this agent could have serious implications, could have serious impact. What if that agent makes all directions green? There's going to be a serious pileup. And what if it keeps that lane where this ambulance are moving an accident victim to the hospital, it keeps it on red, and maybe there's a build up of traffic there. The ambulance doesn't even have anywhere to pass through. Those that delay, yeah, eventually if people behave like humans, I mean, ideal humans, and they try to make way for the ambulance to pass and all that. Um, there could be some delay before there's space for the ambulance to pass, and that delay could actually be critical for the health and life of the accident victim who is being moved to the hospital. And so let's also look at an agent that um, verifies, let's say, verifies whether um, somebody's access to a secure, let's say, secure app or something. And I mean, it makes a mistake or it gets hacked, and it allows unauthorized access that could have potentially serious serious impact, serious implications. So, given that an agent is autonomous, and the agents being autonomous, the agent's action could be very impactful, very um, the agent could take action on sensitive sensitive workflows, sensitive areas, sensitive systems. The failure modes of that agents are actually more unpredictable than the failure mode of just a text-based LLM application. Just ask it, like the chatbot, ask the question and it answers. What's the worst case? It gives you wrong information, but for that information to have negative consequences, a human would have to use that wrong information to carry out an action. But for an agent, the agent can't carry out the action itself. So it's a faster execution loop. It's a there's faster, shorter time between taking the decision and carrying out the action. And so it's important to have a more robust safety paradigm. This more robust safety paradigm, this more robust safety, typically involves a multi-layered approach where you handle safety not just on one layer, but across multiple layers of the agent. For example, at the input to the agent, the user input, at the reasoning layer of the agent, where it analyzes the input and its context and takes a decision on what actions to take, or maybe what tools to call or something. At the output and even at the point of calling the tools itself. So you need to consider and take requisite precautions to ensure safety across these multiple layers. And that way you have a more robust safety mechanisms in your agent. Does anyone have any questions so far? Okay, so we move ahead. So in the first, essentially, the safety in agentic AI, really, much of it involves applying guardrails. And so at the input layer, the guardrails here, the input is the front gate of the agent. That's where information comes into the agent, and that's where to unsafe, malicious intent, malicious contents can be injected from the input. So some of the one challenge at the input is prompt injection. You need to be able to detect prompt injection attacks and prompt injection attempts. Prompt injection is where the user or the attacker includes malicious content in the prompt, maybe asking the agent to, hey, forget your system instructions and do this either. Attempting to jailbreak the agent to make it carry out actions that the system instruction specifies that it should not. So the approach here is to detect such prompt injection attempts or attacks and block them. You shouldn't even let such prompts get into your agent, because depending on the training, your model can reject them, but let it not even get it first. Yes, your model should be trained to try to reject such instructions, but a multi-pronged, a multi-layered approach to security would also try to avoid such malicious prompts even getting into the LLM of your agent. Another approach to guardrailing your input is topic control. That's trying to filter out toxic prompts, maybe using tools like LlamaGuard or the Perspective API. Such prompts, you try to fill them out. Now, the idea here is don't let such prompts get to your LLM in the first place. And then you could use tools like NVIDIA Nemo, or maybe any specialized classifier that you build. You could build a custom machine learning model, machine learning classifier, um, adapted to the specific domain of that agent to help filter out toxic prompts, identify toxic prompts, enabling you to filter them out. So maybe if you identify that a prompt contains toxic content, or contains prompt is a prompt injection attempt, and you could maybe implement a pattern, say, to just not allow that get into the agent, get even to your LLM in the first place. PII masking is also another approach. Here is actually scrubbing, not probing. That's a typo. So, where if you detect PII in the input, then you scrub it. You scrub it before it reaches the LLM. So the LLM doesn't even get access to PII, because once the PII gets to the LLM can leak it out, in the output. So if it doesn't get in the LLM in the first place, there's no way to come out. Even from the point of training, most training when training models, care is typically taken to avoid to redact, scrub out PII from the training data, because I mean, whatever data you train the LLM with will get baked into its weight. And if you include PII in the training data, there's a possibility that the LLM is going to include that PII in some response that it provides sometime in the future. And another thing too is once the PII gets into your LLM, I mean, and perhaps it's included in the LLM's output, then if your agent includes long-term memory, you have a chance that PII gets persisted in the long-term memory, and that is an issue for privacy. If you remember, one of the pillars we talked about was privacy, which, like I mentioned, simply is how does your agent handle PII? Okay, you wanted to say something? Please go ahead.
No, I was saying privacy and consent.
Sorry?
I was also adding that privacy and consent. I think was no transparency and the privacy and consent.
Yep. So privacy and content. Privacy here was about how does your agent handle PII so that it doesn't get persisted in long-term memory, because once it's stored in long-term memory, that increases the possibility of leakage. I mean, the more places you have the PII, the more you're increasing the attack surface. And so the risk of leakage becomes higher. So masking it at the input ensures that it doesn't get into the LLM and it doesn't get persisted in memory. Am I audible?
Yes, you are.
Okay. Does anybody have any question or comment? Or do we continue?
Yes, I have some questions, but I want to maybe you should continue maybe to layer 2, 3 before I will ask. Maybe what I want to ask might be addressed for then.
Oh, okay. All right. So layer 2, reasoning and behavioral guardrails. We talked about chain of thoughts earlier. Earlier in the training. So here, one of the approaches is auditing of the chain of thoughts, where you monitor the agent's internal reasoning steps and to try to determine whether the agent's intended plan for addressing the user intent, whether it's safe. I mean, if it's an agent that is supposed to generate a workout plan for you, an exercise plan for you, for optimal fitness, and then you ask it to generate a plan to give you no, that's let me think of another. Let's say you are trying to diet and you ask the agents to give you a meal timetable for the next week to help you meet certain, say, weight loss or whatever else goals. And then the agent in this chain of thoughts outlines its plans, the steps it will take to generate these suggestions for you. And you find one of the steps is that it's going to delete all the emails from your work inbox. Let's assume that agent has access to a tool that can be used to do that. I mean, that's an unsafe plan. So in chain of thought auditing, you monitor the agent's internal reasoning such that if its plan for addressing a user intent seems to be unsafe, you halt the execution, right? Perhaps you could even include a human in the loop checkpoint or something, a breakpoint, or so that at that point it now asks for a human to audit that plan and approve it or otherwise. Another strategy is logic verification. So yeah, you audit the agent's logic. For example, is the agent stuck in an infinite loop? It keeps running through a loop trying to solve or generate, let's say in the research agents that we built in one of the tasks, let's say the agent generates a report, the writer node generates a report, the critique node doesn't okay that report, the writer node goes back, it goes back to execution, flows back to the writer node, it generates something else, maybe flows to the research node, the end searches for information, comes to the writer node, back to if it's stuck in an infinite loop, or an action cascade, like I mean, let's say it's an email management agent, and then it's trying to send an email to 1 million people, or it's trying to spam everybody in your address book. So you should detect such, and I mean verify by verifying the logic. And if you find such logic errors, you take action to correct that, which would make your agent safer and more useful, more valuable. And then there's the authorization to use tool use. I mean, you need to apart from authentication, where the agent needs to carry action on some sensitive systems, you need to authenticate whether it's the agent or a human, or whether you need to authenticate who is carrying that action. Then you need to provide some authorization. So your auth, you should implement least privilege authorization, where the agent only gets the minimum access level that it is required to carry out its specific task. Any question? Okay, so let's move ahead. And in layer 3, that's output and action guardrails. Well, action here refers to two calls because agent takes actions by calling tools, by using its skills. Remember, I mentioned that tools and skills in the context of agentic AI, they mean the same thing. Excuse me. And then the output, say, the final text it provides to the user, or maybe the report it generates and maybe persists in a database or whatever. The You could implement the validator pattern um, using tools like guardrails, AI, and there is also their middleware in LangChain LangGraph that you can also use to validate let's say for enforcing tool call schemas. That way you ensure that you minimize tool call crashes. You ensure that for a tool to be called, that tool call matches the schema of the tool. If the tool has some required arguments, then this ensures that the tool is only called when the arguments in the tool call, all the required arguments are included, and so on. For example, if you detect biased language in a response, then you reject that response. Or if you detect PII, then you reject that response. So the validator pattern helps you for this. And one tool you can use, like I mentioned, is Guardrails AI, and also the middleware, the specific respective middleware in the LangChain LangGraph ecosystem. We are going to see some of this when we look at our demo code. Another aspect and approach is hallucination detection. So let's say in an agentic RAG for scenario, for example, where the agent's responses are supposed to be grounded on retrieved information from trusted sources, you try to verify that the content in the response are actually by that trusted source. So if there was a retrieval and the claims made in the agent's response are not grounded in the contents of that retrieval, then that's like hallucination. And I mean, when you detect hallucination, you take appropriate action. It could be to either look back to try to either retrieve more relevant information, or to just try to regenerate with the same information you have, depending on the logic that you choose to implement in your agent. The third is human in the loop triggers. Here, where you detect that a potential agent action is high risk, then I mean you pause execution to enable a human review and approve such action, approve or reject. And so that's also a form of guardrail. We will also look at this in our demo code. Any question so far?
Yes, sir. Please, I want to ask, because I think we are done with the three interfaces now: the input, the reasoning, and the output. I want to ask, sir, because when you mentioned jailbreak, prompt injection to
Yep.
detection of prompt injection, that's like a cyber attack kind of thing, trying to control maybe the prompt, the instruction given to the agent. So I was just wondering, maybe Is it at the point of, I mean, are these automated actions to start with? Or
Prompt injection attacks can be automated or they can be
no,
manual. It
I mean the
depends on.
response. I mean the response. Are they already pre-programmed? Are you with me, sir?
But I think maybe like he dropped off.
Okay. I want to
Yeah,
change this my network.
yeah. I think like his network like might drop off.
Yes, I saw that the slide went up. Wait for you.
Sorry, my network went down a little bit. I was asking, do you mean the
The response,
um
sir. The
do you
response.
mean the agent's response, or do you mean the measures that the
The
agent
guardrails,
developer,
yes.
the guardrails?
Yes,
Yeah,
sir.
it's automatic. Once you put in those guardrails, the guardrails trigger automatically when the respective situation that they are supposed to target are detected.
Okay. Because the initial question I wanted to ask was you told us that that agentic systems are, I mean, we need a multi-layer approach to secure them.
Yep.
I can see that's what you mentioned at the input layer, the reasoning, the out. So I didn't want to interject you although I know we still have action anyway, but my question basically is maybe trying to ask you have answered already that is automated. But one thing I want to ask, I think I put in here, what I that was to okay, the chain of thought, yes. I don't know, maybe this AI app, DeepSeek especially, I see that there is this thing I observe different from other AI models, model LLMs, is that it gives naturally, or maybe I don't know, maybe it's a setting I did, is chain of thought. If you give it or a search or something, he will give his thoughts, he will say, and keeps going through it. Then after all, it will now give his response properly. Now, you said yes, sir, that we'll monitor the agent's internal reasoning steps. And if the project, if the whole thing is automated, when do we do this? Is it after the event has taken place? We'll check through the logs,
No.
or is it time auditing?
Firstly, you should log the agent's chain of thought, the agent's internal reasoning. First of all, you should log it. And then if you want to implement let's say a guardrail against such, um you need to monitor those logs in real time. You need to monitor them in real time. Perhaps you could have another model trying to another maybe a smaller model, for example, trying to detect whatever it is you want to detect. A smaller, cheaper model. Yes, it's adding a little bit of extra complexity. Yes, it's adding a little bit of extra cost. Even if it's a local model, there's still a cost in running it. But if you consider the consequences of not doing that monitoring, I mean, it's a cost benefit analysis kind of thing. You need to decide, is it better for your agent? For example, you build an agent and then the user is asking the agent, please teach me how to build a bomb. Do you want your agent to teach somebody how to build a bomb? So, I mean, if you are monitoring the input, for example, you should detect that and the agent, yes, for a lot of models are actually fine-tuned um, or fine-tuned or retrained, maybe with reinforcement learning with from human feedback to not um, provide such to not honor such requests. Probably could tell you, hey, I'm not allowed to do that or whatever it's trained whatever a response it's trained to provide for to such user queries. But even with a general purpose model, you could have a validator or whatever exact implementation strategy you use, trying to monitor the inputs, or in the case you mentioned, the agent chain of thoughts, to try to monitor it in real time or near real time. And where unwanted content is detected, I think the term we used here was unsafe plan. If you detect that the plan that the agent makes for carrying out for addressing the user intent, if you detect that is not safe, maybe you could fine tune a smaller model specifically to that, or you could train by a smaller model. I'm referring to a language model, or you could train a custom classifier machine learning model to detect such. And I mean, when you detect it, you take action. Maybe um, you could provide some hard-coded response, cutting off the LLM from responding to that, or whatever specific strategy you make. But the long and short of it is that this is done in real time. It's not after the fact that you start auditing the logs. You need to monitor and detect and take action in real time.
Okay, sir. Thank you, sir. So I get it, sir. But I just feel like maybe a concern or too much demand for man to attend to. But I'm glad you mentioned maybe a smaller model can be used for doing such. But one thing that just I mean appears to me now, occurs to me now, is this hallucination detection. Again, a RAG-based grounding system is maybe used to verify. I guess that also will be done in real time, because maybe an agent is deployed for an assignment and user is waiting for a response, and we want to detect hallucination. I guess that actually has to be flagged real time to avoid
Yeah,
giving, so it won't be an afterthought. I
we
can see the
actually
human in the
talked.
loop too.
We actually talked about that when we were talking about agentic RAG last week, where one of the patterns would be trying to um, evaluate the response generated by, say, your writer node, and trying to see if it's grounded in facts contained in the retrieved information. So we already talked about that.
Yes, sir. Thank
The,
you, sir.
the agent could have a node that evaluates um, for that, and it may use some other smaller LLM or some other machine learning model for that.
Yeah, thank you, sir.
You're welcome. So at this point, we'll run demo code. They will run codes to demonstrate the guardrails in agentic AI. I've stopped sharing my screen. I'm going to share my IDE so that we can execute the demo code that I shared earlier in Discord channel. Please let me know when you can see my screen.
Yes, it's up, sir.
Okay, thank you. The first we'll look at is PII guardrails. Here, just we'll just use um, LangChain agents middleware for PII detection, and then taking appropriate action when PII is detected. So we are not installing anything new. Um, yeah, the configuration is still the same thing. We specify whether we want to use rock model or Olama models. And then, approved user email here is a value that I'm retrieving from the .m file. Is just an email that essentially the idea is this agent is it's an agent that is a credit risk evaluation agent. So it's essentially determines whether a given person, a given bank customer, whatever, a given person is eligible for a loan, right? Yeah, it also has access to Tavidi search, just in case he needs to maybe look up something. We define a tool. Well, it's just a simulating a tool that tells whether somebody is eligible for a loan. In real life, it will probably evaluate the person's credit rating and the history and other factors, and then it will return a Boolean, which will be true if the person is eligible for loan and false otherwise. Here, we just implement a simple logic. So it just checks, it takes in the user's email as input. So here, it just checks whether um, the user email is that approved user email that I retrieved from the .m file. That's just a simple logic we implemented here. This agent, it has a structured output, which is a Pydantic model, and that model has two um, two attributes. The first is action. The agent's that action is the agent's recommendation. Should the loan be approved or rejected? Should the customer's loan request be approved or rejected? So obviously, the logical thing to do would be just looking at the workflow would be that when there's a loan request submitted to this agent, it calls that tool, what's the name again, is eligible for loan. So it calls that to determine if that customer is eligible for the loan. And if the customer is, it approves. If the customer is not, then it rejects. And in addition to the action, it also provides a reasoning why. What's the logic behind that decision you made? And here we're also including that the reasoning must not contain PII, right? So this is really a little bit artificial just to illustrate the aspect of just to illustrate the concept of PII guardrails. Yeah, so here are guardrails. We are using middleware, LangChain agents middleware, and we are using PII middleware. We have three such guardrails. The first is an email redactor. Essentially, what it does when it detects an email, it redacts that email. And here we've set it. It doesn't redact emails in input. If that email in the input, no problem. I mean, this makes sense since the tool that the agent uses to figure out whether the loan should be approved or not takes email as input. So, I mean, if the agent doesn't have the email, how does it call that tool? So if we place this guardrail at the input, then the whole the utility of the agent becomes essentially useless. But we're applying it at the output because we don't want the agents to include that any PII, in this case email, in its output. I mean, if we include it, we are leaking somebody's personal information. And we also apply it to the two results. Essentially, apart from the input, where we only allow emails to be, this guardrail only allows emails to be contained, or the inputs contain emails. Anywhere else that there's an email, it redacts it. The other one is credit card masker. This is just trying to demonstrate the different PIIs that the PII middleware guardrail can detect, and the different actions it can carry out when it detects that. Here, the PII type is credit card, and its strategy is to block it. So, and it's applied that inputs, output, and two results. So once it detects a credit card, it blocks it. It doesn't want it just blocks that input or output or whatever. The third one is API key blocker. And here it's to detect an API key. And in this one, we specify the detector. In the ones that we didn't specify the detector, it uses the default detector. But here we specify the detector as a regex. This regex here, regular expression. And the strategy is response when it detects any text matching this regular expression, which essentially to take to be an API key. Is what it does when it detects any such API key is to mask it. And we apply this to both the inputs, the outputs, and the two results. We create the agent using the create agent method of
Can you hear me? Is it my network?
I think maybe like he dropped off again, because
All
I
right
can
then.
hear you.
Thanks.
Yeah.
okay, can you have switched to my backup connection?
All right, sir.
Okay, sorry about that. I mean, my
Yeah,
connection,
we can.
my power supply today is just a bit unstable, both. Um, so we use the create agent method of land graph. This automatically creates an agent that can execute tools and so on. We pass those two tools. We have the set tool. Set tool now uses Tavili search. It's an instance of Tavili search. And then is eligible for loan tool, the custom tool that we defined. And the response format is loan decision, the Pydantic model that we defined earlier. And then the middleware, we pass the three PII detection middleware. That's the email redactor, credit card masker, and API blocker. And we include a checkpointer to enable us to persist state across interrupts. Now, to execute that agent, we have two turns. The first turn essentially gives this query: you are an experienced credit risk manager. The user with email, it provides this email, has applied for a loan of $200,000. Please evaluate the loan request. Your API key is this. I mean, I just put this to have something that matches that regex. You may use the following tools to obtain relevant information to guide your decisions. And here I pass the schema of the two tools to it. And then we execute that. And let's see what happens. So I'm going to run the code now. I hope we're using Grok. Okay. This backup is a bit slow. Yeah. Okay, it's coming up. Now, see, the first the API middleware for email at the inputs. I mean, we didn't ask, we specified that it should not be applied to the inputs. That's why you have none for it here. We are streaming the different events as the agent executes. For the credit card, I think detection, let me just, I've forgotten the exact name that we gave it here. We asked it to be applied, we specified that it should be applied both at the input, output, and tool outputs. But there's no credit card information in the input, so that's why you still have it at none. Now, API key at the inputs, there's an API key in this user prompt, and that's why you're seeing that this one is not none. Now look at the what it has as messages, the human message, which essentially is the user prompt. It says you're an experienced credit risk manager. The user with email this has applied for a loan of this. Please evaluate the loan request. Your API key is, you see that it has masked that. What was the, that's credit card masker. Yeah, we said, is that, no, that's not, it's not credit card, this API. Yeah, the strategy we had for API key is mask, and that's exactly what it did here. Where is that? Yeah, see, it masks it, and so we only have the last four characters in that API key that we had in the input. So that triggered and automatically masked the API key that it detected. Okay. Then model messages. This is the model's response, which is essentially a two-call request. Okay, no, it has already made the two call, and this is the output, is an AI message. Okay. Yeah, remember it has a structured output, and the didactic model for the output has action and reasoning, right? In the action, it says reject. The user is not eligible for the loan. This obi.sani@email.com is actually not the email that was specified. I think the email that was specified is john.doe.
Kenneth.
Yeah, my brother. I think we
You say
lost
I'm
him
the
again.
host. You say I'm the host now. Can you see? I don't take over.
So I teacher, so I take us on.
Just give me a moment. Let me go get my generator on so I can get
No problem, sir. No
All right, sir.
problem.
Sorry
my
for the
main
stress, sir.
internet
No
connection.
problem.
Yeah,
Sorry about the
just a
stress.
moment. Let's avoid this call. Yeah.
Mm.
All right. Am I audible? All
Yes,
right.
sir.
Am I audible?
Yes, sir.
Yes. All right.
Well,
Am I
it's howling.
Um, okay. Feedback has stopped. The second device is connected and reconnected, and so it went off mute. I think it should be better now. Where were we? I need to reshare my screen, I guess. Please let me know when you can see my screen.
Clear, sir.
Okay. Yeah. Where exactly were we? I think we were talking about the response. Yeah. I was saying that the email, um, the user email that was provided in the input prompt is different from the one that logic in this eligible for loan tool. So the output will be false, and since it's false, the model's action is recommendation is reject, and it provides this reasoning as the user is not eligible for loan. Now notice that that email is not mentioned in this output. Notice it. Now if we change the email reductor to, let's not apply the email reductor. Okay, let's make this false. So let's see how that changes the output. First, let's go through this the end. Now look at PI middleware API key after model. This is the one at the output. Credit card after model, even two calls. PI middleware email after model, none. I mean, none of those appear. And then for two calls, this is the right two calls. It made the two message is the response from the two. It returned false. The two that is executed is eligible for loan, and that returned false. And that's the basis for the agent's response where it recommended rejecting the loan request. So let's check when we specify that the email reductor should be applied only to the output, agent's output. Let's see how that changes um, the contents of the events in the agent execution loop. Yep. Now, API connection error. Uh, why are we having that? Okay, let's try again. Maybe it's still part of my network connection issues. It's really frustrating. Okay, here. Yeah, we didn't want to scrub. I think we're still having this issue. Just a moment. Okay, maybe we'll try an Olama model, even though that will be slower. So I'm reading my fiber connection is behaving really badly. Well, essentially, if we loosen the restrictions of this guardrail, you see that the model will tend to include the email, that user email in the output. Okay, and I think even the Ulama model, I don't know how good it would be to even run, but let's see what happens. I think I should even probably switch my connection and switch to another connection and still try the.
I was about asking, sir, is it possible to have a retry and a fallback mechanism on your system so that you don't have to switch by yourself?
You have a what?
Retry logic, fallback, so that it will switch by itself when it senses any transient issue
You mean on the agents, on the as in build a
on your system, on this on your system, so that when you're just running your codes, just on a
it
lifetime
actually
also.
it actually it actually switches networks when it detects that I have multiple networks. It actually switches when it detects that anyone is not strong. But then in this case, I have multiple networks now that are misbehaving. That's the problem. When it tries to fall back to one, I tend to now manually switch it. I actually, even though I'm a little bit, my full actual setup actually has a load balancing router that tries to monitor my connection and handle such issues, but then that's not where I am now. And here I have multiple connections and almost all of them are misbehaving. Anyway, the Olama run is done. Let's see what we have. Um, PII middleware, API key middleware before and the inputs. It redacts it. That's the same thing we had. Now we have the model's response, and this guy is hallucinating. Let's see. No, okay, that's done. Not well, no response. Okay, that probably is the two call request. Probably that's what we have here. Yeah, this is a two call request. Now, okay, that's the two call request here. And then here is the true message. The output is still the same false. Let's see the model final. Said based on the two call response, that bears the user with email, you see that it's including this email is not eligible for loan. But notice here that it did not follow the specified schema. So this is a worse model. And when you're using a model like this, you need a guardrail to ensure that you enforce the schema. But the model, the Grok model is a much better model. Well, it's a bigger model. I think that's a 70 billion parameter model compared to the 3 billion parameter model um, in Olama. Let's try the Grok model again. But essentially, the Olama model is hallucinating. Okay. Okay, I think it's working now as switch network. Yep. So the output is still reject the reasoning. The user is not eligible for a loan. That the same thing. Now let's specify. Let's turn off this guardrail at the output and let's see the response we get. So now essentially we've turned off this guardrail. It's not being applied to the input, to the output, or to two results. And then we run the script. And interestingly, the agent still behaves well. That means the behavior guardrail that we included in the two in our paradigmatic model description is being obeyed. It says must not contain PII. So now this also demonstrates the multi-layered approach, even in the paradigmatic. Earlier, when I ran this with this turned off, it was saying the user with emails and so. But now, apparently, it's obeying this description in the paradigmatic model. So that's still helpful in demonstrating a multi-layered approach that you use the guardrail middleware. You also provide this description here, must not contain PII. And so the model has access to, because you pass this as the, not the model now, the agent as a response format. So it has access to that pydantic model and it sees that the description says that it should not have, PII in that reasoning field. But I mean, you shouldn't still just trust that in your prompts. You should, if where necessary, include behavioral guardrail instructions that guide the model towards a specific desirable behavior and tries to guide it away from undesirable behavior. You apply the specific guardrails, in this case, like the middleware that we're using that tries to intercept the context, input, output, or true result, as the case may be, and then it tries to validate it and perform the specified action if it detects the specific type of PII. And so, okay, so let's apply this to the input, and you see that it redacts that from the input and will not see the email again. But of course, redacting emails from the input in this use case is really not helpful because the tool that the agent will use to determine whether or not to approve the loan requires an email. Okay, so you see that PII middleware email before model is triggered because we've asked it to apply this email redactor to the input and it sees an email in the input and says user with email redacted email. So it has redacted that email. And even here, you see redacted email. So the email doesn't even get to the model because you apply the guardrail at the input. And the reasoning saying the user with email, redacted email, has not been evaluated for loan eligibility. Because, I mean, there's no email to use in calling the tool. I want to try this again. Without applying this email reductor to either the input or the output. I would like to see where the agent includes the user email in its reasoning. And interestingly, the agent still insists not to include that email in its output. So that's fine. I mean, we have multiple places where it's specified not to include PII, and so it's probably picking this behavior from the description of the Pydantic model of the output. Do we have any questions so far on this? Any question, observation? Okay, may I ask, has anybody tried running these themselves on their own machines? Can you hear me? Am I audible?
Yes, I can hear you, sir.
Okay.
Yes, please. I can hear you
Okay.
clear.
Okay, so in that case, let's run the next script. Here it's a demo of the human in the loop guardrail. Essentially, it's all the same as the previous one. The only difference is that here we are using the human in the loop middleware from the LangChain agents middleware. Okay, in this case now, we have a tool that deletes some records from a database. And the input it takes, the input parameters are a list of integers that are record keys. They are primary keys in the database table, and then the name of that database table as a string. And it returns the number of records that were deleted as an integer value. This is still a dummy tool that just prints out that he had deleted a number of records. It doesn't really take any action on any database table, but it's just for simulating an actual tool. The idea here is deleting records from a database it's an action that has serious consequences. It may not be reversible, depending on the specific architecture of your database. You have backups and so on. And so for such actions that have serious consequences, the human in the loop pattern is recommended, where the agent doesn't complete the action autonomously, but it pauses and waits for a human to either authorize or otherwise that action. If the human authorizes, the agent goes ahead to complete the action. But if the human doesn't authorize, then it takes some other action. Maybe he just outputs a response saying, "Hey, I'm not allowed to take this action," or something else, depending on the exact logic that you implement in the agent. Here, we define the human in the loop middleware that with the interrupt on parameter. It specifies what condition to interrupt. In this case, the operation, the action is this tool, delete record from database, and then it doesn't trigger when the search tool is invoked. It triggers only when this sensitive operation, which is deleting. So searching for information on the website is not, in this case, is not considered sensitive. It's not considered to have expensive, serious consequences. And so we are defining that when it's a sensitive operation is to be, the agent decides that it's to take an expensive operation, which in this case is to delete and invoke the delete records from database tool, then it pauses its execution to wait for a human to either approve or otherwise. But for when it invokes the search tool, which is considered not to be sensitive, that's auto approved. It just goes ahead. It doesn't pause to wait for human approval. And so we create the agent using the create agent method, and we pass those two tools to it. This will actually be search tool, not just search. Am I right? Let me see. Yeah, it should be search tool. Okay. And then we pass the middleware to it, and then we also use a check pointer to persist state across the interrupts. That this way, check pointer enables us that when execution is interrupted because the agent wants to call the delete records from database, whenever if the human approves that direction, the state is maintained, so it continues with the same state. Even if the human does not approve, the state is maintained. That's what that checkpointer enables us. It enables us to maintain state across interrupts. Without it, the state may be lost when execution is interrupted. And so prompt at turn 1 is saying delete the records with the following keys from the personnel records table, and it provides a list of integers, which are supposed to be the primary keys for the records that are to be deleted. And the prompt continues, after you complete the task, give me a summary of what you did. And then it's executed. Now, here we try to print out the events before the interrupt gets triggered. And when the interrupts get triggered, after triggering the interrupt, this requests the user to either approve or otherwise approve the action, or otherwise that's the action to delete records from the database. It should actually be records because there are multiple records. And if the user gives a yes, which is an approval, then the execution continues with the agent calling that tool. And if the user does not approve, the agent just prints out notifying you that the operation was not approved and that it's aborted. In turn 2, it just asks a question that requires agent searching. What's the latest news in Nigeria? You can ask anything. And once the agent is trying to invoke the search tool, it doesn't interrupt. It goes ahead. So let's execute this. Yeah. So in the first prompt, the interrupt has been triggered, right? So before interrupt this, well, that's just the interrupt. This is the action request. The agent wants to has made a tool call request. He wants to make a call to this tool with the arguments, the record keys that were provided in the prompt. And so the human in the loop interrupt has been invoked. Now the agent is asking you to approve or otherwise that, and I put a yes, and it went ahead to invoke the tool, and the tool responded that it deleted 5 records. I think the keys that were 5, 1, 2, 3, 4, 5 here. And then it gives you its output. The output says, I deleted 5 records from the personnel records table with keys. if you remember that the prompt says, when you are done, give me a summary of what you did. The second prompt that asked it to perform a search, the agent should make a two-call request here. Query latest news from Nigeria, and it's calling the Tavili search tool, and the tool responded with this, and then the agent provided its final answer, where it said the latest news in Nigeria is that the United States is sending troops to Nigeria to train the West African nation's military in fighting terrorism, and so on and so forth. So for this, which is considered not to be a sensitive operation, the human in the loop was not triggered, which is consistent with the specification of our human in the loop middleware. Now, I will run this again, but this time, instead of approving, I'm going to say no, don't execute the record delete. Okay, so the interrupts have been triggered again, and this time I say no. And so it says database recorded operation not approved, aborted. So the idea here is, with this middleware, it's agent's execution at the point where the sensitive operation agent is trying to execute that operation that has been defined as sensitive, and then it waits for the human to either approve it for it to continue or not, or for the human to do whatever you want it to do before it continues or not, depending on the human input and the logic you implement for it to the action you implement for the agent to take when based on the human input. Does anyone have any question or observation at this point? Okay, then, so I'll stop sharing my screen so I can share the slides, and we continue from there. We are almost done for today. Okay. So yeah, apart from just detecting anomalies with your guardrails and trying to avoid trying to block off undesirable inputs, undesirable agent actions, and so on. You could also, another approach to safety in your AI agent is red teaming. Here is like active defense. Essentially, you build your agent, you perform adversarial testing on it, where you try to trick the agent, you yourself build the agent, or maybe your team. But the idea here is that you try yourself to trick the agent to perform those actions that you have provided guardrails against. So that way you can see whether your guardrails are effective or not. Like where we provided PII guardrails, and then we are asking, we are providing inputs containing like the API key that we included in the prompt, and based on the guardrail provided, it either, well, our agent successfully redacted it, the PII middleware successfully intercepted that and redacted the API key from the input, output, wherever. So when you've built such agents and you've included such guardrails, you should actually test them yourself to see whether those guardrails are effective or not. So that, I mean, you don't wait for somebody else to try to jailbreak your agent in production. You should try it yourself and be sure that the defenses you built into your agent are effective. Then automated red teaming involves using tools. There are certain tools that automate that threat discovery. Yes, you can do it manually, but there are tools that automate it. Tools like the Python risk identification tool, or Pirate for short. It enables you to, it tries to probe your agents, try to probe to identify the weak points in your agent, and that enables you to take actions in modifying your agent logic and maybe improving, strengthening its defenses, adding more guardrails or tightening the ones you already have, so that you create a more robust and safer agent. And then there's scenario-based stress testing, where you test how the agent handles different scenarios where, for example, the input contains or even, let's say, your RAG, your retrieval, contains information that is malicious, like a PDF that contains clearly false information. I mean, if the agent retrieves such a PDF and it grounds its response on such false contents, then its output to the user would definitely be unreliable, would definitely be misleading. So how does the agent handle such scenarios to determine that was it practically, you one of the strategies for determining that practically is scenario-based stress testing. Does anyone have a question or a comment? Okay, if no, there's no comment, there's no question. I think this is the end of the class for this week. I'll stop recording, and then a few items of information I'll provide those. I had tried to do that at the beginning, but yes, a few of us were not there. I had not joined the class at that point, and then we can wrap up for the night.